Hi everyone. Today I brought a question from the topic of thermodynamics. So let us discuss the question. It says, consider two identical homogeneous balls A and B. So they are identical. Okay, mass is same, specific heat is same, radius is same. Okay, with the same initial temperature. So starting temperature, initial temperature is same for both of them. One of them is at rest on a horizontal plane while the second one hangs on a thread. The same quantities of heat have been supplied to both balls. So heat given to both of them is same. Let us represent Q as heat supplied. And this is same for both. We need to discuss the final temperatures of the balls are same or not. So some students think that okay, heat supplied is same, material is same, specific heat will be same. So final temperature also will be same because initial temperature is same. But they are missing something, and that is as you heat the system, there will be expansion, isn't it? And this will expand this way because the string we are assuming is fixed, and this will expand this way, right? Isn't it? Because the floor is fixed. So you can see the center of mass of this point has come down slightly, whereas center of mass of this system has gone up slightly. So this is the displacement of center of mass. So that you keep in mind. So because there is expansion, there will be some work done by the system, and that work done has to be included to decide whether the temperature will increase or decrease. So we need to go for first law of thermodynamics. In physics, whenever you get doubt, please go with laws. Don't go with your feelings because sometimes it may give you wrong answer. So the first law of thermodynamics, float, the first law of thermodynamics says that when heat is given to a system, a part of that is used to increase the internal energy, which is responsible to increase the temperature. So this is responsible to increase temperature. And the remaining heat is used for work done by the system. So this is work done by the system against the surrounding, against the surrounding or against the external forces. So here, to know whether whose temperature finally will be more, we need to check this one is more for which body, because this is same for both the bodies. So let us bring this on the left side. So what we will get? Q minus W. Now this is same. So that body's temperature or internal energy will increase more, whose W will be less, isn't it? So whichever system does less work, for that system the internal energy will increase more, and therefore temperature final will be more. So we need to check what is the work done by the system against the surrounding forces. So now let's discuss what is the work done by ball A against the external forces. What forces are acting during its expansion? Well, there will be some atmospheric pressure force, isn't it? And since atmospheric pressure force will act inwards and the ball is expanding this way, that means work done by pressure, atmospheric pressure, will be negative because forces are acting this way, displacements are this way, opposite direction, right? So work done by atmospheric pressure during this expansion is negative. That means work done by system against the pressure, which is this, will be positive. So this is work done by A against the atmospheric pressure. Atmospheric pressure. I hope this is clear. This is something like if I want to move this marker from here to here slowly, then while going up, gravity is acting downwards. So gravity does negative work. So therefore, I must do positive work during this displacement. So pressure is doing negative work. So this system has to do positive work. Now there is another force which acts, that is gravitational force. And you can see gravitational force is acting downwards, and for gravity we know it acts at center of mass, and since center of mass is also falling down, displacement of center of mass and gravity both are down in case of ball A. That means work done by gravity is positive because force and displacement are in same direction. So therefore this implies work done by A against gravity will be, if this is positive, this will be negative. Okay. Now what about ball B? Well, atmospheric pressure force is acting here also inwards, and here also it is expanding. So here also work done by B against atmospheric pressure will be positive, same as here, because pressure force is doing negative work. So the system has to do positive work against the pressure force. What about work done by B against gravity? Well, you can see gravity acts downwards, but displacement of center of mass is upwards. So in case of ball B, work done by gravity is negative because they are opposite direction, force and displacement. Since work done by gravity is negative, work done by system, which is B, must be positive. So you can see for ball A, work done by A against pressure is positive, but work done by A against gravity is negative. But here it is positive in both cases. That means work done by B against the surrounding is greater than work done by A. So now tell me which one did less work. A did less work, isn't it? Therefore, whichever does less work, for that body, the internal energy will increase more. So delta U for ball A will be greater than delta U for ball B, and therefore change in temperature of ball A will be more. But initial temperature was same, so final temperature of A will be greater than final temperature of B, and that is your answer, right?